In this video, we're going to get some more practice factoring trinomials that have a leading coefficient of 1. However, you'll notice that all of the examples on this slide don't have a leading coefficient of 1. They have something else out front there, okay? So in the directions it says factor each trinomial completely, making sure to first factor out the GCF. Okay, so all of these have a GCF that we have to factor out first, and then we'll concentrate on finding the product of two binomials. So in this first example of 2x squared minus 4x minus 70, I notice that 2 is common to all of the numbers, right? All of the numbers there are even. So I'm going to factor a 2 out. So that'll leave x squared minus 2x minus 35. So now that trinomial of x squared minus 2x minus 35 is factorable. Okay, so we've got 2 times the quantity of two binomials, but we've got to find what they are, right? I know I've got an x and an x. Now look at the signs. So I'm looking for two numbers that multiply to give negative 35. That means that one of these has to be a positive and one of them has to be a negative. If you like the treasure map and want to use it, we're looking for numbers that multiply to give negative 35 and add to give negative 2. Okay, so 1 and 35 isn't going to give us 2 no matter whether they're positive or negative. And of course the other factor that I think of is 7 times 5. Okay, now if one of them were negative, say negative 7 were negative and then we had a positive 5, would that give us negative 2 if we added them? Negative 7 plus 5 does give us negative 2. Okay, so we're going to have x plus 5 and x minus 7 as our factors. Okay, now when we check it, take what you ended with and multiply it back through and see if you get what you started with. So leave the 2 alone and just FOIL for the moment. Okay, so you're going to have x times x is x squared, x times minus 7 is minus 7x, 5 times x is 5x, 5 times negative 7 is minus 35. There we go. Okay. All right. So we're going to have 2 times x squared minus 2x minus 35. Okay, and then distribute the 2 back through, right? So 2x squared, 2 times negative 2x is minus 4x. And 2 times negative 35 is minus 70. Okay, so 2x squared minus 4x minus 70, that's what we originally started with. Okay, very good. Okay, now moving on to this one, it looks a little bit big, you know, with all of the big exponents and things, but again, we're looking for a GCF here. Okay, so 4y to the 5th plus 48y to the 4th plus 144y cubed. Okay, the first thing I'm going to ask myself, I look at the lowest number there, which is 4. Does 4 divide 48? It does, right? 4 times 12 is 48, okay? And does 4 divide 144? Does 4 go into 144 evenly? It does. If you need a calculator to do that, you can go to it. I'm thinking to myself, well, 4 goes into 14 3 times, right, with the long division. And 4 times 3 is 12. The difference of 14 and 12 is 2. 4 goes into 24 6 times. So 36, right? Okay, so 4 is something we can pull out for sure. Now, what's the lowest power on the variable? Y cubed, right? We can pull a y cubed out. All right, so 4y cubed times y squared gives 4y to the 5th. 4y cubed times 12y would give 48y to the 4th. And 4y cubed times 36 would give 144y cubed. Okay, so now the next question after factoring out that GCF, that was a big one, we just need to figure out if that trinomial y squared plus 12y plus 36 factors. Okay, so let's do the little treasure map. Now, careful here, we're going to think about signs. Everything's positive here, everywhere, right? So we know our two numbers are going to be positive as well. We're going to have y plus something times y plus something over here. Okay, so we've got to have a product of 36 and a sum of 12. So the first thing that pops into my head, I just always think about the times table, right? So 36 has a lot of factors. You can go through them, 1 and 36, 2 and 18, 3 and 12, etc. But because 36 is a perfect square, in my head, I went straight to 6 times 6, right? And 6 plus 6 is 12, so that's great. So that's fully factored. 4y cubed times the quantity y plus 6 times the quantity y plus 6, which we could also write as 4y cubed times y plus 6 squared. Okay, checking it. Start with what we ended with, and I'm using the 4y cubed times y plus 6 times y plus 6 because I want to do that foiling first. Leave the 4y cubed alone. So y times y is y squared. In the middle, I'm going to have plus 6y twice, right? And then 6 times 6 is 36. Okay, so 4y cubed times y squared plus 12y plus 36. We're just working it backwards, right? Now to distribute that through, 4y cubed times y squared is 4y to the fifth. 4y cubed times 12y is 48y to the fourth. And 4y cubed times 36 is 144y cubed. Very good. All right, in this next one, negative 3t cubed plus 45t squared minus 150t. All right, I'm looking at the lowest number, and I've got a negative out front too. Whenever you have that, pull the negative out too with your GCF, because you want the leading coefficient to be 1, not negative 1 or negative 3 in this case. So we want to pull negative 3 out of there if we can, and negative 3 is a factor of 45 and of negative 150, right? So if we pull negative 3, and we've got a variable, right? So t cubed, t squared, and t. So we can pull a t out of there. Negative 3t, okay, negative 3t times t squared is negative 3t cubed, right? If we pull negative 3 out of 45, what times 3 is 45? 15, right? So we're going to have minus 15t, right? Because we're pulling a t out too. Okay. Does that stand to reason? Negative 3t times negative 15t is positive 45t squared. Yes. And now we're also going to have to pull out negative 3t from negative 150t. So let's see, 3 times 50 is 150, right? So we're going to have plus 50, and we're pulling a t out too, so just plus 50 there at the end, right? So negative 3t times 50 is minus 150t. Yes. Okay, so I always talk that back through, right? Like when you're factoring, you kind of reverse it and then multiply it through again. Do you get what you started with? Okay, now let's go from here. So we've got negative 3t, and now we're going to see if we can factor this trinomial. So we've got t times t, which is t squared. Okay, so what are we looking for here? We got to get two numbers that multiply to give us 50 and add to give negative 15. All right, because our sum is negative but our product is positive, both of these numbers have to be a negative, right? Negative times a negative is a positive, but when we add two negatives, we get another negative. Okay, so they both have to be negative. And so just start thinking about the factors that might give that to us. Right off the bat, I'm thinking the obvious one. I mean, you could go through the list of them starting with 1, 2, etc. But I'm thinking 5 times 10, right? Negative 5 minus 10 is negative 15, right? Okay. So our factoring numbers are going to be negative 5 and negative 10. So our factors will be t minus 5 and t minus 10. Okay, now checking this, always start with what you ended with and work it backwards. So I'm going to leave the negative 3t alone for the moment, and I'm just going to do the FOILing. Negative 3t, and what will we have there? T squared, right? In the middle, minus 10t, minus 5t, plus 50. Eek! Okay, so we have negative 3t times the quantity t squared minus 15t plus 50. So negative 3t times t squared is negative 3t cubed. Negative 3t times negative 15t is positive 45t squared. And negative 3t plus 50 is minus 150t. Now, this last example, it's a little bit different. We have a GCF to factor out there, but notice some of the numbers we're dealing with are decimals. So we have negative z squared minus 0.2z plus 0.15. All right, the first thing I want to do, the only thing I can factor out there is a negative, and please do so. So we've got when we factor out a negative, all of the signs change, right? So our trinomial is going to be z squared plus 0.2z minus 0.15. So with that negative out front, we're going to see if we can factor this. I know it looks a little bit weird with these decimals, but I think we can do this. Okay, so because we have a negative 0.15, that means that see, we're going to have a z and a z, right? Z times z is z squared. But one of them is going to be positive and one of them is going to be negative, right? Our factoring numbers there, because we have negative 0.15. Okay, so here we go. Treasure map. So we have negative 0.15 as our product, and our sum is going to be positive 0.2. Okay, so I think of some of the obvious things like 0.3 times 0.5 is 0.15. So just think of the factors of 15, right? 0.3 and 0.5. Now, one of those has to be positive and one of them has to be negative, right? Assuming those are the factors. And so what combination would give us positive 0.2? Well, if I had negative 0.3 and I added 0.5, I should get positive 0.2. Right. Okay, so we're going to have z plus 0.5 and z minus 0.3 as factors there. Okay. All right, so let's check it. Okay, so starting with what we ended with, negative quantity z plus 0.5 times z minus 0.3. And we're going to leave that negative out front alone. We're going to FOIL this, so z times z is z squared minus 0.3z plus 0.5z minus 0.5 times 0.3 is 0.15. Negative times z squared, I'm going to clean up the middle term there. Negative 0.3 plus 0.5 is plus 0.2z minus 15. All right, distribute the negative through, so I have negative z squared minus 0.2z plus 0.15. All right, and this is what we started with, right? This was our original statement. Okay. So what we did here in this slide, these 4 examples, it was really more practice with not only factoring out a GCF, but also factoring trinomials whose leading coefficient is 1.